welcome back to BridgeView. Now that the tower crane is on the scene, the western tower is rising out of the river very quickly. And we just finished the big concrete pour for the eastern pile cap. That's at the base of the eastern tower, so it too will also come rising out of the river. Each pylon or tower leg has 10 sections, also called lifts. And today we are pouring one of the 8 sections of the western tower. So here today to tell us a little bit about the pylon building process is Aaron Beyer. Aaron is the pylon field engineer from Kiewit Infrastructure West. Hey Aaron.
How's it going, Deanne?
Great.
Good.
Can you tell us a little bit about the pylon building process for the bridge?
Yeah, so first what we do is we start with building a rebar cage in our yard, and then we load that onto a truck, or with a crane we take it down our trestle, and then we pick it with the tower crane and set it in place. The upper lifts we tie onto a frame. After we get all of the rebar tied into place, we erect some forms. Those forms get built and tied together, and then like today, we get our concrete labor crew, and they come up and they pour the concrete for the tower.
Okay, and so then once the concrete is poured and cured, you remove the forms and start all over again on the next section of the lift. Okay.
That's right.
So, can you give us some numbers? Tell us how much concrete and rebar are in some of the lifts, so we get an idea of how big, these pylon lifts are.
Right. So our first lift is actually our biggest lift of rebar. It goes into the pile cap that we just got done pouring over on the east side. It's about 60 tons of rebar. The one that we can see today, that one has about 13 tons of rebar in it, and it's got 42 cubic yards that we're pouring today. Our first lift had 182 cubic yards in it.
So out of the 10 sections or lifts, you pour 9 of them in place basically. So, but the 10th one, I understand, you actually create not on the tower itself, but elsewhere, and then lift it into place. Is that correct?
Yeah, that's right. We'll call that a precast segment. So the ones we're building now, the one we're pouring today, that's a cast in place concrete lift. And then the other lift for lift 10, it'll be a precast cap that will come later. So we have 2 precast caps that we're building. One in the yard now, which is our temporary precast cap for the temporary cable stay operation, which I'm sure you'll talk about later. The other one is the permanent cap that will stay on the bridge and be there for generations to come. And those will go and tie into when we use the saddles on the bridge, which this bridge has saddles.
Right.
Most bridges, or a lot of bridges, they use a different type of anchoring system. They'll anchor down at the bridge deck and then anchor up in the pylon. Then you need room to get up into that anchor in the pylon, and you need room to get to it on the bridge deck. So this is a saddle design, so the actual cable goes down from the bridge deck anchor up through the pylon down to another anchor on the other side. It makes it a little bit leaner, a meaner bridge just for Portland.
Great, and I know that we'll talk about saddles a little bit later when we talk about the whole cable system and how that works. So great. Well, lots of good information. Thanks a lot for joining us, Aaron.
No problem.
Appreciate it. That's all we have time for today. We'll see you next time on BridgeView.